Today you're going to learn how to solve using the substitution method. Before you do that, there are a couple of things you have to remember. You have to remember how to solve equations. So first, see if you can solve this equation. I'll give you time to solve this equation. You want to pause and then you want to come back and see how you did. Okay, so you have to move all your variables to one side of your equation and all your numbers to the other. I like to move my variables to the left side of my equation. Sometimes people like to build this little wall so you know you're going from one side to the other, and that's why you have to use inverse operations. The opposite of a negative 4x is a positive 4x, so when I move it, I have to do the exact same thing to both sides of my equation to keep it balanced. That goes away. And now we're going to bring down what we have. Combine your like terms. 1 plus 4 is 5x. Bring down your minus 3 equals 32. Now we want to move our numbers together, so we're going to add 3 to both sides of our equation. Keep it balanced. And we have 5x is equal to 35. But we still have x with 5, so we have to undo our multiplication by dividing both sides of our equation by 5. And we get x is equal to 7. Okay, that's one skill you have to have today. And you'll end up going back and taking this x equals 7 and substituting it into an equation to find the y. Because remember, when you have a system of equations, the point where those lines intersect, or those two equations, when you graph them, wherever you see an intersection, that's the solution. Right now I'm just showing you some prerequisite skills on how to solve in case you forgot. So now, let's look at solving for y. Suppose I give you 2x plus 3y is equal to 15. Now if I give you a system of equations, you're going to want to solve for one of these variables, x or y, so that you can substitute what you have into the other equation. For now, you need to remember how to solve for a variable, so let's just solve for y. Well, that means we want y alone. So what needs to move? You can go ahead and pause the video and try it on your own and come back. Okay, so we need to move at 2x. Subtract 2x from both sides of your equation to keep it balanced. 2 minus 2 goes to 0, which is what you want. If you put plus 2 on both sides, you end up with 4. So you wouldn't end up moving the 2, but you'd end up making it higher. So that's how you know what to do. So we're going to have 3y, and keep the color code going. 3y is equal to, these are unlike terms, so you can only rewrite them, you cannot combine them. Negative 2x plus 15. I like to write it in slope-intercept form. If you want to put 15 minus 2x, that's fine also. But we're still solving for y, so the opposite of multiplying by 3 is dividing every term by 3. So now we're going to have y is equal to negative 2/3 x. 15 divided by 3 is 5. And you've just solved for y. So make sure you understand these, and then you can move on to problem number 1. Okay, so if we look at this chart right here, it's how do you solve a system of equations by substitution, and here's an example. I'm going to actually give you a printout of this, you probably already have it, and I'm going to go through each piece with you. And then I'm going to give you another little organizer where you can do a couple of problems using this method, and then you should be okay. So let's look over here. Step 1, choose one equation to solve for x or y. Well, since we already have a coefficient of a 1 here, although it's negative 1, it would be easier to solve for y. So let's solve for y in this equation, and whatever we get for y, we plug in to the y for that equation. So what we're trying to do is see where this line and this line will cross each other when we graph them. Alright, so to solve for y, we need to isolate y. So first, let's undo this 2x by subtracting 2x from both sides of our equation. And now we have negative y is equal to negative 2x plus 9. We still have an issue because we have negative y. So there's a negative 1 there that we do not see, We divide each term by that -1, and that's how we get y isolated, because we want positive y. Is equal to a negative divided by a negative is a positive, and positive divided by a negative is a negative. So now you solve for y. So you take this equation for y right here, and you plug it in for y. So I'm going to take this right here, and I'm going to put it into my other equation in place of y. And that's called substitution, because you're substituting. So now we use that equation, 3x plus 2, but now instead of using y, we're going to use 2x minus 9. Because the whole idea is that you want to have the exact same variable throughout your equation so you can solve for it. If you have two different variables, you can't solve at this point. I'm going to teach you another method where we can work that out, but right now we cannot solve. And even in the other method, you got to make sure one variable is eliminated. Okay, so this is 3x. What property are we using here? Distributive. Good. 2 times 2 is 4. And 2 times 9 is 18. And we have a positive times a negative. Don't try to add that 3 and 2, because you're supposed to multiply before you add. And in addition to that, this is not like terms with the 3 until you multiply it anyway. Now we combine our like terms. Because 10 is on the other side of the equal sign, we don't multiply 10 by 2. We only multiply what's in parentheses by 2. 3 plus 4 is 7 minus 8. So 7x minus 18 equals 10. We're solving for x, so we're going to add 18 to both sides of our equation. Undo the subtraction. We have 7x is equal to 28. What would you do now? Good. Divide both sides of the equation by 7, and we get x equals 4. But we're solving this system. So if we're solving a system, we should have an ordered pair for our answer, or we would have no solution if the lines are parallel, or we would have infinitely many solutions if we have a line on top of a line. So now we only have half of our solution, and that's the x value. So in place of x, we know we have 4. But how do we find y? Good. So you take your x equals 4, substitute it into one of your original equations, and that is how you can find y. So let me erase over erase so you can have some more space to look at this. Okay. So now we can plug in. You can choose either equation, because since it's a system and the solution should be on both of those lines, you can choose one or the other equation. I'm going to choose either equation is fine. I'm going to choose the first one. 3x plus 2y equals 10, but I know x is 4. So in place of x, I'm going to plug in 4. So we have 3 times 4 plus 2y equals 10, which is wonderful, because now you have only one variable and now you can solve for it. You multiply. 3 times 4 is 12 plus 2y equals 10. Now we go back to our solving. We want to solve for y, so we're going to subtract 12 from both sides of our equation so that it goes away on this side. We bring down 2y is equal to -2. And what would you do next? Good. Divide by 2. And y equals 1. So we're saying that our ordered pair is 4, 1. And we're saying that this is where those two lines will cross. Sometimes you will be given an ordered pair, and it'll ask you if it's a solution to the system. And so you would plug in x equals 4 and y equals 1, and that's how you would find your answer. So I'll have to do that with you as well. So if you wanted to check yourself, you would plug in 3 times 4 is 12. 2 times 1 is 2. And then you do 12 plus 2. So that tells me, uh-oh, what did I do? -1. So that's perfect. A negative divided by a positive is negative. So now I can see that when I check, 3x means 3 times 4, which is 12. 2 times -1 is -2. So you have 12 plus -2, which is 10. And then you have to do it with your other variable. Well, 2 times x. X is 4. 2 times 4 is 8. 8 minus negative 1. So look at that. You're going to have 8 minus negative 1. Well, that becomes plus or positive. 8 plus 1 is 9, and you want 9. So that's how you check yourself, and that's how you determine if you have an ordered pair that's a solution to a system. Okay, so let me go ahead and let you get this all in and digest it. The final answer here is 4, negative 1, which means that is where those two lines will cross when you graph them. Okay.